Hi everyone. Hopefully people are trickling back in from their breaks. I hope that session went okay. I saw a couple of good maps coming out, well, really good maps actually. There's some really fantastic stuff that people are doing, some really creative maps. I'd love to kind of think of a way for us to have some kind of collaborative document perhaps for sharing our QGIS tips, because some people seem to either have used it before or are just picking up really fast, and there's some really nice creative uses of this coming out. And also if people are willing to, I'm seeing, like I say, some great maps in going into Slack. There will be points for these as well. So there are definitely PSG points available for the best maps that I see popping into those groups. Also, I haven't forgotten your discrete event simulation models from last week. They are definitely still on my list to have a look through. It has just been a slightly hectic week. So we will get back to that. There's a couple of questions coming up that I don't think we've got time to go through right now, but I will make sure that I answer these in Slack after this session. So someone's asked, Jin's asked, couldn't seem to get past categorization. Filtering on joined MSOA layers was throwing up an error, so I'll have a play around to recreate that and come up with a solution. Also, Sib saying that they were unable to create another map or add another map in the print layout, classifying another field updated the initial map. So I think the solution there is potentially to duplicate that layer and to add that as your second map. But we'll have, again, I'll have a play around and provide a solution with two separate classified maps so that we can see how that was done. Before I carry on, were there any other questions that people had? I seem to keep losing my chat window, unfortunately, every time I try stopping sharing on Zoom. Oh, there we go. No, that was it. Cool, right. Hopefully, people can see my screen. So we are now going to go on to mapping in Python using Geopandas. So why carry on beyond QGIS? Can't we just use QGIS for everything that we want to? Well, it is a really great bit of software. I completely think it's fantastic. We wouldn't have taught it otherwise, and I do often use it when I get first, new geographic data set that I want to play around with. It's a really good place to do that initial exploration. And some of the examples we showed previously and some of the examples I'm seeing coming out, you can create really high quality maps within QGIS. However, there are an awful lot of benefits to knowing how to create maps in Python as well. You may find that one is better than others in some certain situations. You may find one clicks better with you, but I'm going to try and explain to you why I think Python mapping is so cool. So one of the big things is you can do your data preparation without having to move around between bits of software. So that final bit of data we were using where we'd had all the normalized columns, that was all done, all that processing was done within, I think I might have done it within R actually, but the point still stands, Python. You can do all of your processing and your actual mapping within one workflow rather than having to move between different tools. It's a lot easier to adjust the calculations that are feeding into your map, and you can use all of the things we've started to cover about pandas, but there are loads more so that you can filter your data sets easily, you can create additional columns, so on and so forth. You can join it with other data sets like these ones where we're maybe looking at how many people live in each LSOA, use those bits of data together to create these new columns. It's very powerful and flexible. By starting to bring in what we learned about loops and functions, you can start to make maps to show different aspects of your data very quickly. So here I've actually used 6 lines of code, actually produced 25 maps from this data set. There is a lot you can do in a very short amount of code, and then you can start to reproduce and reuse that code. When you start combining it with things like Quarto, which we're going to cover in a later part of the course. Quarto is a really nice set of tools to allow you to create reproducible reports, reproducible standalone dashboards, all sorts of things. You can create large number of reports for different areas, different services, all within these sort of automated loops. You can start to automate your regular reporting tasks, and by using this, you can start to include maps in your regular reporting tasks, or just create a really polished, high quality document for people to work with. As well, By using Python maps, you can build them into interactive web-based tools. So again, later on in the course, we'll be talking about how to create web applications for your stakeholders to use. So here's an example from one of the previous HSMA projects. This was Glenn Ubley and a couple of friends that were a couple of colleagues within HSMA 4, I think this was, and they created a tool that allowed people to look at different possible configurations for travel to cardiac centres in Kent. And all of these maps are generated in Python on the fly as different combinations are tried out. So what we need is Geopandas. So we used a little bit of standard pandas in, I think, the second or third of the Python sessions. Now we are going to work with something called Geopandas, very similar to pandas. It just built on pandas itself. So it extends pandas data frames, these sort of almost the Excel within Python, the tabular data manipulation package, to also allow it to work with these geometric data types. It has a lot of knowledge about how to deal with coordinate reference systems, what on earth is a latitude and longitude point, all that kind of stuff just makes pandas that little bit smarter so it can deal with all of that for you. Now, word of warning, Geopandas is known for some compatibility issues with other packages, and that's why environments start to become so important. All this faff that we've gone through to give you the tools to create these different environments, and I will recap this before we kick off with the session, with the actual exercise. But if you install Geopandas into your base Python environment, your base Conda environment, you may begin to experience odd behavior or have some issues. It's not certain, it won't definitely happen. This may not be such an issue with newer versions of Geopandas, but just in general, Geopandas is one of those ones that can cause a few problems. So keeping it in its own environment can make sure that it's not going to cause issues. There are also, as I say, Google Colab alternatives provided, so you can do everything today within Google Colab, still exactly the same code. So what is Geopandas doing? Well, let's go back to our pandas data frames. Pandas takes multiple series of data and joins these together to make a data frame. So the anatomy of a pandas data frame, this is our index over here, our column. This can be, just numeric, effectively row numbers, row 0, row 1, row 2. Remember that everything in Python tends to start counting from 0. Then we have a series of columns, and effectively every time you look at a column in a pandas data frame, it's something called a series. It's a special data type that has some fantastic properties. By being a series rather than just thinking of it as a column, there are all these additional things we can do to it. They have special functions, special methods that you can apply to a pandas series. Join multiple series and an index, and what they create is a data frame. So here, what we've got, this particular data frame we're looking at, you'll get quite familiar with these particular data frames by the end of this this session. Also, I've just realized Dan has said, never ever install Geopandas into your base environment. I'm assuming there is some history here with how badly it breaks things. So, but yes, it's coming back to the series. So joining your series into the data frame. So we've got rows here with sectors, so LSOAs in this case, actually sector LSOA meaning the same thing in this instance. Each one of these is actually a hospital in Cornwall. I can't remember all of the acronyms. I think that's the Royal Cornwall Hospital in Treliske, for example. Bodmin Hospital, not an acronym, but each one of these is a travel time. So actually it takes 40 minutes to get from this LSOA sector to this hospital, 31 minutes to get to this hospital, 60 minutes to get to this hospital, and so on. So you'll get very familiar with this. But what's important right now is that these series are our travel times. This series, this sector, is another series, but that's just our list of LSOAs. This index, our row numbers, so on. Geopandas takes these series objects and just makes it smarter. It makes it able to deal with point data, line data, and polygon data. I'll talk about what those are in a second, but it also adds in the abilities to read in various geographic data formats. So it can read in, like we were looking at before, shape files, geopackages, GeoJSON. So everything we've been working with so far in QGIS, you can work with in pandas, in Geopandas as well. So you still have an index. Anything that's not a new geographic data type will still be a standard pandas series, but you will have this special geo series as well. It's a special kind of series with all these additional things. And you can see here, we've got point data. It's recognized that this longitude and latitude is actually a special thing of it in its own right. We can do extra useful things with this, which I'll talk about in a second. Now, every Geopandas data frame has what is called a geometry column. It might not actually be called that, but under the hood, it is recognized as a geometry column. Various Geopandas methods will automatically apply to that geometry column. So you will use your Geopandas data frame and you will say something like plot, and it will go, I know that I'm a Geopandas data frame, and therefore you want me to plot the geometry column. You don't have to specify I'm, looking at geometry. So this geometry column, for example, here is as I say, it's a geoseries and it's a special kind of column. Now, point, line, and polygon data. Point data, very familiar with from that first QGIS session. It's just all these, if we're going back to our collisions, all these individual points that are usually referenced by latitude and longitude or northings and eastings. Remember, northings and eastings is the sort of the British standard for coordinate points, but a lot of data sets you'll use will have latitude and longitude. And Geopandas is really good at allowing us to move between these two. So if you've got one data set that's got latitude and longitude, another that's in northings and eastings, don't worry, Geopandas can sort all that out for you. Line data, you don't tend to use this so much. These are rivers. That's about the best example I could find in this particular instance. So don't worry too much about line, but you may find you do actually want to show some direct travel routes, perhaps. So that line may come up, but primarily what you'll be working with is point data and polygon data. Now, polygon is just effectively any sort of shape, really, but a lot of the shapes we'll be working with are these irregular shapes, these boundaries, like our LSOAs. So this is just a random LSOA I've picked here. And the polygon data kind of tells how to set up this outline, this boundary. So reading in geographic data, there's a couple of different ways you will want to know how to read in geographic data. So you can refer to geographic data types that's stored locally. Nice, simple syntax here. It's Geopandas. So you'll import Geopandas. We don't use an alias. So remember when we imported pandas, we had import pandas as PD. You can import Geopandas as GPD if you want to, but the standard recommendation is not to. Just call it Geopandas, import Geopandas, and then you will have geopandas.read file, and you will point to file that you want to load in. You can actually also refer directly to files that are stored on the web. So, be a little bit careful with this, be a little bit sensitive to the people that have uploaded that data. If you're downloading, quite often these geo packages and GeoJSONs can be quite big. So actually just repeatedly downloading that is maybe not the most, the nicest way to deal with their servers, etc. And also, even just think of the carbon emissions. Just every time you're downloading something, you are using energy, so on and so forth. So just you don't want to download a 50 megabyte file 100 times. So just be a little bit aware of that. You can also directly refer to files that are stored within zip files. That's just got a slightly special syntax, but we won't be using that one today. The main ones you need to know about are this Geopandas read file. So if it's a geopackage, a GeoJSON, or a shape file, you'll be using this geopandas.read file method. So I'm going to give you a quick live demo now, a recap of opening things in VS Code and opening and how file paths work and why this is all important. So I'm going to open up a new VS Code window because I know this tripped up a lot of people during the pandas session, just being able to access the data sets correctly. And have, there were a lot of people finding that it was saying no such file exists and so on. So I'm going to show you how to deal with that. I've opened up a blank VS Code window here. The first thing I'm going to do, which is going to make my life easier, is I'm going to open up a folder. So I'm going to go File and Open Folder. And remember earlier, I downloaded this HSMA data. Now, where did I save it? I went into, where did I put it? Well, let's go into where I was working with it the other day instead, and which I also now can't find. Let's go.
HSMA demo, I think that's where you put it.
Oh, thank you, Dan. I'll go with this one now. Oh yeah, HSMA demo. Thank you. So what I'm going to do is I've clicked into HSMA demo in this case. So you can see that I've got a folder, the whole folder here. I'm now going to just choose select folder. I haven't got another folder selected within here. I'm just not clicked onto anything. Select folder. And I have accidentally loaded in the solutions file. Lovely live demo problems. So let's try this again. Let's go to open folder. I'm going to do it a different way. So I'm going to go, basically, let's just call this, I'm going to rename this to module. Can't do that because I've currently got it open. Let's imagine this is called module 3b. It's whatever you've saved your folder in. Rather than clicking into it where you've got these data sets, exercises, etc., you want to be one level up. I'm just going back and forward here, so I'm effectively using these back and forward arrows. So I've clicked on HSMA demo. I'm going to choose select folder. Now, when I load this up, you can see I need to trust the authors. The authors are just Dan and I. No one else can add or remove things from that repository, so you can be sure it's nice and safe. Trust the authors, otherwise you won't be able to run the code that's within there. Now you will be able to see that you've got a series of folders. You've got, I've dragged something out here. This is really not going well. Right, start again. Blame the cold, blame the cold. Right, I'm opening my folder. I'm in my HSMA demo. You should be completely, after seeing this, me do this 3 or 4 times, you want your HSMA demo folder. Don't click into it, click select. In your window on the left now, you've got HSMA demo, you've got all of these different folders. Now, if I load up the exercise, I'm going to go into exercise 3, which is what we're going to be working on in a minute. Now, when I'm going to import my required packages, you'll be doing that, think about the packages that I've been saying about, things like pandas, things like Geopandas. But the main thing to note is the file path. Now, I've generally provided the file paths within the exercises, or there will be at least one file path provided, and you can sort of extrapolate from that. What this is saying is look relative to where this exercise notebook is, and then go up a level. So these 2 dots mean go up a level. So now it's in this main folder. If I open up this folder again within the HSMA demo, so we're in this folder. The 2 dots here have said, please go up a level. So it's gone to here. And then it said, start looking relative to this. So it's gone, please look in data sets. Please look in exercise 3. And now look for this stats 19 counts normalized, etc., etc. So it's just, that's what this file path is doing. That's what these 2 dots mean. They're quite important in this case. If you have downloaded your file, if you've downloaded that folder, unzipped it like we were talking about earlier on in the session, you will not have any problems navigating to the relevant folder because it knows where it is relative to this exercise notebook that we are working on. Other thing, just to remind you, if you haven't worked with notebooks for a little while, up here, mine's currently just saying detecting kernels. It might say no kernel selected. Click on this, choose Python environments, and choose geographic. Now, if you don't have geographic available, like I say, you can either use the Colab links, they are posted in the class channel, or you can go into your start menu, type in Anaconda, or start typing ANA, it should come up with Anaconda prompt. Now, I meant to delete the environment before I did this, so I unfortunately have not done that, so I don't think I'll be able to recreate it. But the main thing I want to tell you to do is go back to where you saved your folder, where you downloaded things earlier. Go into environment, right-click in this top bit. So there again, I'm sorry if you're on a Mac or Linux today, but for the majority of you who are on Windows, right-click up here where it says the environment. Click in a blank bit here, choose copy address as text. You then need to go back to your Anaconda prompt, choose CD, and then you want to right click and it will just paste in the file path that we just copied. Now if I press enter, you'll see it's navigated to that folder. That's where our environment.yaml file is saved. The environment.yaml file is what Anaconda needs to tell it what packages to install, what version of Python to install. If I now do conda env create, and it will be -f, which is basically saying, look at this particular file, and I want environment.yaml. I will share a screenshot of this in the chat afterwards, but if I run this now, basically it's telling me that I already have this environment, but yours will tell you that actually, okay, I'm going to install the geographic environment. This is just a reminder. Remember, this is all being recorded. It will go up on the slides. If you haven't created this, maybe take a few moments to try, but you might fall behind in the exercise. Just this is how you need to create environments. This is what you will need to do for module 4, for the machine learning environment. For every subsequent module, we will be providing you with environment.yaml files. If you just have pure Python, there are videos on our YouTube for explaining how to do this with the requirements.txt file instead. If just use the Colab environments would be my recommendation. If you don't have this environment set up today, use the Colab environments because every package you need is already in there. So I'm just going to have a quick look at the chat before I carry on talking about the Geopandas side of things. I'm adding one for you, but still nagging you. Yes, that is pip. I think some of our environments don't explicitly install pip, and we get a rather interesting warning message. It's not an error, it's just a warning in this case. We've got some so Joel is saying we've got an error when trying to install the YAML file. Invalid name geographic.yml, try the format user package. I think that possibly suggests it's not in quite the right folder at that point. So Joel, I'll catch up with you at some point to try and work out how we can make sure we're definitely in the right place, or if there's something else going on there possibly. Emma has posted how to find these things in Mac. And yep, there we go. So I've Geopandas handling multi-polygon data. Dom, I'm not sure on that one. I believe it can. I will get back to you on that one. Can there be more than one geometry column in a data frame? Yes, I believe there can be. How it handles it in functions, not sure off the top of my head. And yeah, where are we getting to? Is there a good way of finding the name of the environment you've just installed, Ruth? If you do conda env list, I believe that will give you a full list of the environments that have been created. It should, after it's installed, also give you a little pop-up that says conda activate, and it will give you the name of the environment that's just been created. You can also open up the environment.yaml file by double-clicking on it. It will open it up in a text editor, or it might open it up in VS Code, and then you can see in there what the name will be. Jin, you've got your hand up as well.
Sorry, Sammy. Well, I think I see two approaches. One is the YAML file for creating a new environment, and the other is the requirements.txt. I was trying to create one without you having to use Anaconda, and once I've created a new workspace on the module folder within HSMA, trying to create a new environment, virtual environment there. But my VS Code is not able to find a Python interpreter. So the Python.exe file is that something I should take offline?
Yeah, I think we'll catch up. I'll send you a link. So there are still a few booking slots for people that are having issues with environments. So I'll make sure that that's shared after this as well. I think in that case, it sounds like, not working with Anaconda does complicate things a little bit. But I know that a lot of people do have issues with not being able to install Conda. I know we've also got a lot of people with we've had NHSE people, a large number of you have moved over to the common desktop, and it sounds like that is causing issues if Conda has gone missing. So yeah, I will share the booking links afterwards for people that are still kind of need a helping hand with environments. Use the Colab version for today would be my recommendation, and then we will take this offline.
Thanks.
Cool. So right. Back to geographic data, so geographic data types. So if we cast our mind back for a few minutes ago, we had loaded in this Geopandas file using geopandas.read file. Now, when we load it in, actually, it looks just like a normal pandas data set. I'm using something for these screenshots called DeepNote. It's another online coding environment. That's why I've got these extra fancy little things showing me like a scrollable table. But what we have, we can still use our normal functions like .head to show a preview of the first 5 rows. So you can use all your normal pandas commands. When we check the type of the data frame, so we can use the function type, this will tell us that it's a geopandas.geodataframe.geodataframe. If this was a normal pandas data frame, it would just say something like pandas.dataframe. A lot of the time, that's not exactly what you'll be doing. Again, you'll probably be extracting data from your data warehouse if you're in an analytical role, and you'll be turning this into a geodata frame. So back to our CSV file on, in this case, the stop and search file. So when we load this in using the standard pandas.read CSV function, you will get a standard data frame. I've used head with the brackets and just put 1 in here to say, I just want to see the very first row of this data set, please, just to see what's in here. Now, what you can see is in here is latitude and longitude columns. In this particular instance, we have the exact location of each stop and search, a bit like with our Stats 19 dataset, where we had the exact location of each accident that took place. So we've imported it as a CSV. What we need to know is how to tell Geopandas what the geometry should be. So what we need is this little bit of code that says, please create me a new Geopandas geodata frame. We pass in our pandas data frame. We then say, please set up the geometry file. I want you to create this from X and Y points. I want you to look at the longitude first. So remember, we had longitude, which is the sort of across, and we have the latitude, which is the sort of up. Remember we said X, Y, X is horizontal, Y is up. This gets a little bit confusing because latitude and longitude usually kind of go in the other direction. We start with our latitude first, our up. Our longitude is our across. All you need to remember is we want our across first, our up second. If you follow this pattern, it will just always work. We then need to tell it what coordinate reference system we're using. If you're using longitude and latitude, I would recommend using EPSG 4326. This is the standard sort of default coordinate reference system to use if you're using longitude and latitude. So anytime you've got a data set that's using longitude and latitude, just follow this exact format and it will load in absolutely fine. So what we started with was our CSV file that was a data frame. We put it through this little bit of code. We made something. I'll tend to end it with _GDF so I can just keep track of whether I'm working with a data frame or geodata frame at this point in my code. And then we can say, well, now I want you to look at what type this new thing is. And now we've got a geodata frame containing all of the same data. It just has this special geometry column available to us as well. And I'll tell you why the geometry column is so good in just a minute. We can also combine pandas data frames with Geopandas data frames. So going back to what we were doing in that last exercise where we had our MSOA boundaries and then we had a pandas or a CSV file and we joined them in QGIS, you can do exactly the same thing in Geopandas. So for example, we've got a data set of patients who are using a particular type of service. We've counted up how many patients there are per LSOA. And the LSOA, like before, isn't going to allow us to actually plot anything. So what we need is to import a shapefile using the Geopandas read file method. We'll save that, our boundaries as one variable. We'll then import our pandas data frame of the counts, and then we will join the two together. So what we need is a little bit of code like this. So let's say we've loaded in our boundary file. We've got Geopandas read file of some sort of LSOA or MSOA boundaries. We then have a data frame that comes in with a column of counts and a column of LSOAs that those counts relate to. If one of them's got a column, the geodata frame has a column called LSOA 11 CD, so LSOA 11 code. The count data frame, again, it might not be exactly the same name. So in this case, it's just called LSOA. What we need to do is merge the two. We use pd.merge, so we've imported pandas as PD. So PD just means pandas in this case, and we're saying please join the two together. If you're coming from SQL, this is very much like the join methods that you are used to in SQL. We say on the left, I want my boundary data frame. I want my geodata frame, and that's what I'm going to start with. On the right, I want my count data frame. I want you to look at the LSOA 11 code column in this geodata frame. I want you to look at the LSOA column in my count data frame on the right. And then I want you to join the two together. Now, how equals right? I'll tell you a little bit more about this now. If you set how equals left, it will look at everything in this data frame and keep every row. So there might be that you have certain rows where you don't have a count for that LSOA, but it will have kept all of the rows in the left-hand column. If you set how equals right, it will keep all of the rows from my count data frame. And if there's any rows in this one that don't have a matching data set, a matching row, they'll be lost. They'll be dropped out. You'll get a lot more familiar with this. If you're coming from an analytics background in SQL, this will feel more familiar. If you're coming from a clinical background or a any other kind of background, this will feel probably a little bit weird. You'll get some practice with it. Draw on those people within your peer support groups who are coming from that analytics background and will have done a lot of joining of data sets. But the most important thing is basically put your geodata frame on the left, put your count data frame on the right. So when we set up these columns, otherwise your resulting data frame will no longer be a geodata frame. It sets the data type based on the first data frame you are passing in. So Geopandas then, why did we go through all this faff? Geopandas has a really nice built-in method for now quickly plotting your data. So we just take our data frame, and if it's a geodata frame, we can just do dot plot, and suddenly we have a map. You can also then pass a column name in to start coloring the plot by the values in that column. Depending on what your data set is, you may actually struggle to see the impact here, but here it's gone in and it's started coloring some of our LSOAs by this particular other crime column in this particular data set. Works the point data too, so if you've got, say, your stats 19 data set or your stock and search data set, dot plot, it knows that it's points automatically and it will plot them appropriately. We don't have any sort of background here, we don't have any reference. I know that this is sort of, if we carry on down here, it's Cornwall, this is sort of a little bit of Devon, Somerset, and so on, and a couple of random ones dotted around. We'll deal with that a little bit later. You can also colour the points, so again, you can pass in the column that you want to colour by. We don't have a legend here, you may notice. Also going to deal with that later, but for now you can just pass in a column and colour it by that. The plot method, as you may see, feels a little bit lacking, but it just gives you a good idea for how that your data is kind of loaded in correctly, that you've got some data that it can plot. For now, we're just going to do a short exercise focusing on importing that geometry data, and then after that, we'll come back and talk a little about enhancing your plots. Now, a word on the way the notebooks are set up. I structure my notebooks as what I call core, extension, and challenge. The core section is the things I would like everyone to ideally get to. If you are working, you should be sharing your screen. Someone should be sharing the screen in the peer support groups. And what I want you doing is making sure that you bring everyone along on the journey with you to get through those core exercises. That is the main thing to achieve within the session. There are then extension sections. So if you want to push yourself, if you get through the core stuff, you can start working on these extension exercises if you would like to. The challenge section will often go quite a long way beyond what we've taught in the sessions. You will have to go away and look things up. You might have to look things up on Stack Overflow. You might have to go to the documentation. You might need to use an AI coding assistant of some sort to give you some ideas of how to do this code. They will probably also take a lot longer than is allocated during the lectures. They are not obligatory. They are just there if you want to have more practice, to consolidate your learning, to go away and try out more things. They are just there so you have access to them. The other thing that means is when I provide the solutions notebooks tomorrow, you will have a huge amount of boilerplate code that you can go away and adapt for your own projects, for your own day-to-day work. It goes beyond the basics and gives you access to subplots, to more advanced methods, and so on and so forth. So all of the notebooks will be structured like this. The key thing to remember is as long as you've done the core parts, you can stop at that point. You know, you don't feel obliged to go through the entire notebook. Core is what matters. So what we're going to do now is go away and have a bit of practice just of importing these files and doing these very simple plots using the plot method. You'll be creating 3 maps. All of the instructions are provided within the notebook file, so hopefully you won't be having to do too much jumping back and forth to see what you're meant to be doing, but you probably will want to refer back to the slides to see what kind of code you need to be writing. So I'm going to pop you into groups for 20 minutes, but first I will check if there are any questions. Dan, anything you've spotted that I need to get to?
To be honest, so Sammy, I think to be honest, most of the conversation has been around issues with the whole sort of common desktop thing and people not having permissions, and that if I can rant for a moment, this terrible idea that the NHSIT seem to be removing any concept of local storage, which is, by the way, a terrible idea for data science. But yeah, I mean, Sammy's got, as I say, some. If you're having issues, go with the Colab options for now. But yeah, I think most of the problems seem to be related to that. But please, if anyone else has anything else, please jump in. I think a few people have posted some solutions here and on Slack about the issues with Common Desktop and how to get around some of them. So yeah, it has caused problems, clearly.
Yeah, it sounds. I think exactly what you're saying. It's a bit of a nightmare. You know, with Geopandas, as Dan was saying in the chat, you know, it's so important to not install things into an environment that is your base environment. That's why we've gone through all this stuff with Anaconda and, you know, why Anaconda is so important. But yeah, it's everything to do with environments and environment management is a real nightmare when IT departments A, start changing things, and B, you know, don't give you local storage, make you work in certain ways, etc. Like I say, the Colab link is in the class tannoy. Do go and use that, and it should work. There will be a cell at the beginning that loads in the repository for you. That means that Colab can access all of the data files, and the file paths should work entirely the same. You shouldn't have to change the file paths to make them work. But do shout if that's a problem. Kate has asked, will we need the geographic environment after today? You will need it for the session on next Tuesday morning. Tuesday afternoon, we'll be moving on to AI, and there won't, I believe, be an environment needed for that particular session. The thing about next week, I will also be providing the Colab alternative. So, you know, it's great to have the geographic environment long term, especially if you think you might be using some geographic stuff for your project. But for now, you know, don't panic. There is a Colab alternative. Oh, someone has had VS Code completely removed today, so that's a fun one to turn on your laptop and find that's gone. That's yeah. I really hope Colab doesn't collapse under the weight of all of us trying to use it at once, but it should be fine. But yes, this is forever the difficulty that we are facing. We go through the effort as well of trying to make sure that you do have access to these. You know, we don't just do everything online, partially because the rug can be pulled out from under us at any minute. You know, these things like Colab do frequently stop being available. You know, and also when you come to your projects, well, your organization is going to say there's no way we're letting you upload data to Colab. So we know it's painful and we know it's awful trying to do environments when you're new to all of this, but we are doing it hopefully for the right reasons. But I know it can be frustrating, especially if your organization is really not making that easy. But
just on that note, sorry, Sammy, I was just going to. I mean, if anybody, I mean, Sammy and I were talking about this yesterday, and it's clearly it's a major issue because, and I feel for everyone here because this is an intense course where we're teaching you lots and lots of different stuff, and to then have the added issues of IT issues that are constantly changing, complicating things for you, And to the extent where, and obviously we're external, so there's only so much we can do to alleviate those issues. So it's great that people are having those shared experiences. Somebody pointed out it's really helpful that people are sort of sharing solutions on that. So that's really good. I mean, if anybody, what we'd like to do is to speak to the people. So there must be some sort of central body or central people that we can talk to at NHS about NHS IT, because clearly, if the NHS has aspirations to be a data science organisation, which it clearly does, and that's a great thing, that's what we're trying to support, you can't have an IT infrastructure that doesn't allow the basics of how you need to do data science. So if anybody has thoughts about people that we can talk to try and make this easier for all of you and for future cohorts, that would be great, because it's it's not a great situation for all of you. You know, I think Sammy had to spend the first few weeks of this course trying to unpick a lot of your issues that were caused by varying weird things that IT departments had done. It would be great if we could move gradually towards something that where things just work. So yeah, please do share your thoughts.
Yeah, very keen to hear this. Yeah, as Dan says, you know, please do reach out. We want to just try and make this as easy as possible. But yeah, I think the consensus in the chat very much seems to be that yeah, centralized joined up IT, stuff of science fiction. Yep, I agree, Joel. We'd love it. We would. Although the joy always is as well, if they centralize it, we want them to do it right, which is a whole, we have strong opinions on what right means, and it may not be what is agreed with elsewhere, but yeah, we will kind of keep this conversation going, but I will keep trying to provide collab alternatives wherever possible, because I don't want people to not be able to access the exercises just because your IT department are making things difficult for you. So with all that said, we're running a little bit behind. I'm going to give you at least 20 minutes to work on this exercise. I will pop around and see how people are getting on, because I suspect we will still have a few issues with file paths, etc. But yeah, 20 minutes roughly, and then we will come back. Let's say we'll come back at I can't count, 15:15. Is that right? It's been a long morning. We'll come back at about 12:15. I'll make a start on the next section, but we'll probably do the next exercise after lunch instead. So I'm going to open up the breakout rooms, pop into there, open up exercise. So inside the exercise note folder of the repository that you've downloaded, or on Colab, go to Class Tannoy, open up the exercise notebook and start working through. Just have a bit of a play around. So I will see you on the other side. Hi everyone, I think we've got everyone back in the room now. I just want to start off by apologising. Dan pointed out, and I think it may have come from one of the groups, that there was a typo between EPSG and ESPG in one of the exercises, which may have caused a few problems. That hopefully, well, I've made a note to fix that for next time. Also, there was a missing end of the sentence in one of the postcodes exercise extensions. I will also fix that for next time as well. Worth noting, if you do spot any issues that you would like me to fix, if you have a GitHub account, you may not, but you can sign up. You'll probably want one at some point during the course. But if you are on the repository, so when you've loaded the repository in like this, there's a little tab that says issues at the top. And you can always open a new issue that basically, you know, anything that you spot that's a typo, any sort of error, I will try and keep track of them as we go through the sessions. But just for the benefit of those who come after you, these sessions have had a really radical rewrite from last year as well. So we are, you know, I'm trying to make sure that everything gets picked up, but hopefully that will make things better for everyone. Most of the groups I'd seen when we went around had managed to get through the core bits, so you managed to import a couple of geodata files and plots and columns, so that was good to see. In the next exercise, there will be a bit more practice of that, or there may be some boilerplate code that, you know, does that bit for you. So we'll just, we've got 10 minutes now until lunch. So I'm just going to make a start on the slides for the next bit, but we'll actually, the exercise that we would have done before lunch, we'll have plenty of time to go through that after lunch instead. And I'll just rejig a few other bits. Cool. So quickly make sure I've got the chat up as well before I kick back off. And Dan has said, yeah, you'll need a GitHub account for module 7. So, you know, do go ahead and create an account. It's free. It allows you to start keeping track of things as well. So if you want to follow us on GitHub, it makes it easier to find us again. If you want to star repositories of other people's code that you find interesting, that, you know, you may have seen shared on NHSR or PyCom, if you're members of those groups, you know, it's really useful to have a GitHub account. So on to base maps. Stuart has also just asked, could we have a tutorial on how to use GitHub? Yep, at some point I will try and do a quick 5-minute video on just how to, what the main benefits of GitHub are before we get properly on to the full details of using Git for version control in module 7. But yeah, just a quick overview of why Git is so great, why GitHub specifically is so great. Very happy to do that. I love GitHub, can't get enough of it. So, right, base maps. Back in QGIS, we were importing our base map via the XYZ tiles set. Well, a base map is also very useful to us in any maps we're making within Python. So we will need an additional library for this. If you've used the Geopandas, the environment.yaml or the requirements.txt to import this, then to set up your environment, contextually, the base map library will be installed, but you will need to import it at the start of any code where you want to use a base map. Again, on Colab, there is an extra line that runs at the start of the Colab notebook that will install this library into Colab for you. So to add a base map, we just import our original data frame. Now, instead of just plotting it, we will assign it to the standard format to use is AX equals. So AX is just kind of shorthand for axis in this case. What we then need to do is say CX dot. So remember, we imported contextually as CX. We're going to do CX dot add base map. We're going to pass in the figure that we created just now up here. So remember, we've assigned it to AX equals. This is now saying, please add the base map to this plot. We are going to need to pass in the coordinate reference system of our geodata frame. The easiest way to do this is pass in your geodata frame to the CRS argument. Use .crs, so that's saying please access the coordinate reference system attribute of my geodata frame, and please turn this into a string. Please turn it into a bit of text. If you just access the CRS attribute yourself, you can do that outside of this little code block, see what that returns. Quite interesting to look at, but it's more data, that it's not just a nice string that the base map argument can use. Then we also need to set a zoom level. The zoom level will relate to basically how high the fidelity is for the base map. So if you set the zoom level to higher, there will be more detail on your base map. It will also take a lot longer to load. So if you set your base map to, say I'd set it to level 14 and I was this zoomed out, it would probably take 2 or 3 minutes to load in. The base map provider may dislike you as well. If you start doing lots of calls to the base map provider, you may start to get errors if you do lots in short succession. So start with a relatively low zoom level, sort of 6, 7, 8 is a good place to start. If your map is blurry, then you can start to increase it. But that's kind of where you want to start off. Why does the UK look a little bit wider than usual in this map as well? It's because of our coordinate reference system. So in this particular data set, I've used EPSG 4326. I now can't remember whether it's EPSG or ESPG. I'm going to have to go away and remind myself of what that acronym means so I don't keep getting it the wrong way round. But EPSG 4326 to import our data. This is the sort of standard worldwide mapping, but what for the UK, if we want the UK to look kind of the shape we're used to it looking in a lot of the maps with sea day to day, then we will probably be wanting to use the British National Grid, which is EPSG to 27700. Now, let's try just passing in our longitude and latitude and setting the CRS to EPSG 27700. And we've hit a problem. Actually, everything's in completely the wrong place. That's not what we want at all. We're now in C, and this is completely wrong. So what can we do instead? It's almost as simple. It's because we've passed in the EPSG here to 27700, but it was expecting eastings and northings, not latitude and longitude. So we've got two options. If our data set contains eastings and northings, when we set up our geometry column, we just pass in the eastings and northings, and we say our CRS is 27700. But the data set I'm using here only has latitude and longitude. So what I could do is I could go away and look up the conversion. That's a bit faff. What is much better is to use the dot2CRS method of Geopandas. So what I have here is a geodata frame that I've imported in 4326, the standard web mapping coordinate reference system that is using latitude and longitude, and I've said please convert it. And now I've overwritten. There's an equal sign hidden under this. I've overwritten my geodata frame. I've now plotted it exactly the same as before. I've set up my base mapping exactly as before, but you can see that the sort of, for a start, we've now got eastings and northings up and down the side. So instead of numbers that ran from about -3 to 5 or 2-ish or something, and from about 50 to 55-ish maybe, we've got numbers in the hundreds of thousands. That's because we're using eastings and northings now. And compare this to our map that we had first on the left and the map that we've got on the right. The kind of layout of it looks a little bit more correct, arguably. You can kind of work either way. Your maps won't be wrong. It's just worth knowing how to convert between the two. And you will use a lot of EPSG moving around between the two to just make sure that you can work with data regardless of what format it's provided to you in. It's useful to know about that dot2CRS method. How are we doing for time? Quickly finish this section on base maps and then I'll let you go for lunch. So changing the zoom level does, as I say, increase the quality of map. Here we've got zoom level 4. Well, you can hardly even see it's the UK. Zoom level 10, incredibly detailed by comparison, but it took 2 seconds to load that in and 90 seconds to load that in. So when you're sort of benchmarking, playing around, getting your map set up at first, you might want to set the zoom level to lower and then up it as you go through and finalize your map. I'm going to stop there because we're at 1:30. Let you go. We'll regroup at 1:30. We'll carry on talking about how to enhance your Geopandas plots, and then we'll go on and start working with a little bit of travel. Well, we'll then go on to interactive mapping, and if we've got time today, we will start working with travel time data as well. Thanks very much, everyone. I can't see any immediate questions in the chat, but do pop them in there over lunch, and I will address them after lunch, and see you in an hour. Thanks very much.
In progress.
Hi, everyone. Hopefully you have had a chance to have lunch. Apologies if there were any weird noises just then. I realized I turned my mute off just as my coffee machine finished turning itself off. So, but welcome back. We're going to carry on now with some mapping in Python, and but first, I've done a little bit of rejigging just to give us plenty of time for the exercises today. So we won't get on to the final exercise of today. That will be moved to next week, but there'll still be plenty of time for next week's exercises as well. What I'm going to do first is share with you a link to a Menti, a presentation there. Let me just find that link again. I've just lost it. There we go. So just posting into the chat for everyone a link to a Menti presentation. I'll share that a few times as people come back into the room. Alternatively, you can log in using the code 74073766. I'll just add that to the screen as well. But if you could just take 5 minutes just to have a look at basically look at the questions and see what you think, you know, is just getting a sense of how you're doing right now, both with the discrete event simulation that we've done, the QGIS stuff, checking how you're getting on with the environments, all that sort of stuff. So please just spend a couple of minutes now taking a look at that, and I'll turn my camera off, give you a few minutes, and then we'll be back in a sec. But do shout if you're having any trouble finding the link. You can also go to, like I say, menti.com and type in the code if you'd rather do it on your phone or something. So I'll see you in a few minutes. Hi everyone. I think I've seen a lot of responses come in at this point, so thank you everyone. I really appreciate you taking the time to give us that feedback. It really is helpful. I've seen a lot of useful things that I can action already. One of the main ones that someone's pointed out that there are a couple of sort of assumed steps that haven't been explained very well in the slides this time. I have noticed a few of those as I've gone along, and I do apologise for that. I will try and adjust the slides so that when you've got them to refer back to, anything that kind of is a little bit unclear, I've got a note of quite a few things to just tidy up a little bit in that front. The other one is having access to the information in here, rather than just having it in the sort of the slide deck. Or, you know, we appreciate it's not always the easiest to go back and find these bits within the slide deck when you want to refer to them again. We do have a long-term plan to make sure that there is a book like the DES book and the Python book for every single module. It's just taking us quite a long time. They're quite time-consuming to create. I would note that there is within the repository, there is some notebooks, some additional notebooks. One is called, I believe, Mapping in Python. So we'll be working on, you know, that everything used in the example slides today is in there. It's not as heavily commented as I'd like, and it's not as well laid out as I would like. Again, over time, I hope to be able to improve that. But also the solutions files that come out tomorrow will hopefully be a helpful reference to this as well. The other thing is, you know, if anyone's creating additional notes, or we could have like a group note file or something that we could all contribute to. So that's something I'll keep in mind as something that we could do as well. So with all of that said, I will kick back off with a little bit more about Python mapping and enhancing your plots. So just before lunch, we were talking about how to add base maps. We're going to move now on to how to start adding in a legend. So you'll be pleased to know that adding in a legend is extremely simple. Previously we may have coloured something like by gender in this case. We've got our base map. All we need to do is add in to that plot section that we want a legend. We want the legend true equals true to be present. Now, when we're using the plot method as well, everything that is being done with plot is effectively using matplotlib under the hood. So matplotlib we used a little bit at the end of the final Python session, and the great news is that everything that works in matplotlib tends to work within Geopandas plots. So the benefit of this is we can use a lot of the standard matplotlib functions. So for example, to get rid of all these numbers up the side and across the bottom, all we need to do, remember we've saved our plot to the AX variable. We can change what that's called, but the standard is just AX. It's easier if you use AX because you can just remember that and keep reusing that in all your code. But AX equals, we add our base map, we tell it we want our base map to be on this same plot object, and then we turn off the axis tick marks. All we do is ax.axis, and in brackets we put off, and now we get a map that looks a lot nicer and something you'd be more likely to put in front of people. So the other thing right now is our map's a bit small, you're probably finding by default. It's a little bit difficult to see what's going on. The easiest way to change that is to pass in, again, to our plot argument, fig size. We put this inside normal brackets. The first number is how wide the plot is. The second number is how tall the plot is. For now, just kind of don't necessarily think of it as a particular unit or anything, just kind of play around with those numbers to see what impact that has on your plot. The one thing I will say about using it with Geopandas is it won't stretch your plot. It will keep it in the right aspect ratio for the coordinate reference system you have chosen. Therefore, there will only be so much impact if I change this to 100 wide and 10 tall now, it wouldn't really change from what you're seeing on the screen in this instance. So the next thing as well is that when you are looking at your map, you may find that it's really not zoomed in enough to see anything of much use. So for example, this map here, we've plotted the total number of crimes by LSOA, and it looks like some of these areas might not be purple if we look really closely, if we zoom in, but it's really not helping as much. So what do we want to do here? We can change the axis limits. So again, I've left the axis limits turned on here, because it's quite useful when you're doing this to be able to, or the axis tick marks even, it's quite useful when you're doing this to be able to see what's going on, to be able to see what extent your map is. So remember, we're working in eastings and northings up here. That's so 100,000 is, 100,000 in northings, 86,000. What I've done is I've said, please set my X limit to between 285,000 at the furthest left and 300,000 furthest right. The Y limit, 85,000 at the bottom, 100,000 at the top. And this has just allowed us to zoom in to the relevant area of the map. So here you can see, again, I've got the axis limits or the axis labels visible, and I can just kind of have a look and go, oh, okay, right, that area looks interesting to me. Let's work out roughly where it is. And you can just keep tweaking that, keep zooming in, keep zooming in. Now, what you may notice here is that we've got our legend showing that actually the highest values we're seeing across this entire area are around about 12, 13,000, but we haven't got any of this on our map. And actually a lot of the values that we're seeing within this zoomed in bit are somewhere within a maxing out maybe 8 to 10,000, but it's just not giving as much insight into the variation within this area. But so there's some ways that we can actually filter this differently to adjust the map accordingly. So what I've done here, I've made reference, we can use this in the previous bit of code as well, but I want my X minimum to be, again, 285,000. I want my maximum, the far right value to be 300,000. So we've got commas between it. That means that 285,000 gets assigned to X min, 300,000 gets assigned to X max. Same with Y min and Y max. Now, what we can do, and this is a little bit confusing, this is different to contextually where we've been using the base maps, but unfortunately the method is also called .cx, so that's a little bit of a thing to remember. But what I've taken is my geodata frame of crime figures in this case. I've used .cx, and then I've used this syntax to say, please basically filter my data frame to within these axis limits. Now, what we then get is a map that just shows, you can see actually it's removed all of the additional LSOA boundaries around here. They've not been included in our final plot. And what we then get as well, you can see that our upper axis limit is now 6,000. It's based on the highest value within this subplot rather than the whole value the whole data set as it was in this previous one when we just set the X axis limits. So these are just two different ways, depending on what you're trying to do within your data set. Do you want that axis to be consistent, that legend to be consistent across different plots? Well, then you probably just want to use this. If you want to actually zoom in on a particular region and have the details of that region and work with just that region, then this may be a better method. You might find yourself using combinations of the two as well. So actually here, what I've done is I've added a base map as well, so nothing different here. I've just added the base map. I've still cut my axes based on this. I've limited to just this area, but now we've got the base map around it. We can do a couple of things here. We can start to change the opacity. Now, opacity within the plot is actually called alpha. That's just they're just the same thing effectively. So rather than typing in opacity equals, you're looking at alpha equals, and it will just change how see-through, how transparent our whole choropleth is. So you can start to see some of the details underneath it in our base map. And all of this works for point data too. So actually you can change the alpha of point data, and it starts to give you a little bit of a better idea where these regions of density are, rather than all the plots just entirely turning into one mass. You can start to get a sense of just how many points are there by the overlap. Color schemes as well. So here I have colored my data set, my point data set by the gender column, and I've used, instead of the standard color map, I've passed in a CMAP color map. And it doesn't look too intuitive. BWR, it means basically blue something through to red. So you can see our females have come through as blue here, our males have come through as red, which is different to the default. This does also work for polygons. So here I've passed in a color map called reds, and you can see instead of what we were having previously with all of these sort of purples and yellows, the default, we have it going from a pale color through to a dark red, which is sometimes quite intuitive. Now you can get a full list of the available color maps from within the matplotlib documentation. This is just a small sample of what's available, but you can see that we have reds, oranges, greens, blues, etc. Or we can have these color maps that start at one color, go into a central color or a pale color in the middle, and go out to a different color. And if you've got categories, you may want to use these qualitative color maps that are designed to be quite distinct between different categories to make it easier to tell them apart. Now, showing polygon boundaries. Again, we just go back to our plot method. You can see that we can just start adding extra bits into our plot method over time. And we want the edge color argument here. That is going to make the boundaries of each LSOA more distinct in this plot. There is another parameter you can pass in called line width. So edge color, we just pass in any color, we write it as a color. You can also, if you know what a hex code is, or you can pass in a hex code instead, or you can Google hex codes and you'll find a little picker that gives you a nice image of, well, let's actually quickly do this. If I can get the Google screen up, and I can't because it's hidden behind all my Zoom. So I'm just going to Google hex colors. Hex color picker, sometimes Google, yep. So if you type in hex color picker on Google, you get this nice color picker here. You can start to move around until you find a color that you like. Let's say I want to make my boundaries red, and you can see this value here, I'll zoom in a little bit, is what's called a hex value. It's a hash followed by a series of numbers. That hex value will correspond to the color we've selected. You can then paste that in where it says edge color, and you'll get that color instead. Hex colors can be used in quite a lot of places within matplotlib. You may come across them the further into matplotlib you go, and graphing in Python in general. It's just a nice computer readable way of identifying a color. So, like I say, you can also adjust the line width parameter, so play around with that if you want to. I could set the line width parameter to a smaller value to make these lines a little bit less thick, which is really valuable when you start getting onto lots of small plots on the same larger plot figure. Point sizes, we can also adjust the size of the points when we've got a point map like this. So actually, this is the default. You can see that this isn't hugely helpful. All I need to do is to my plot argument, I pass in marker size. So then I can start to adjust how big each marker is. We can also pass in a column so that the marker sizes actually relate to a particular value. So here, instead of just having a single size for things, I'm working with a GP set of data, a set of GP data with a list of how big each practice is. What I've done is I've gone, please look at my GP data geodata frame. Please pull out the list size column for me. And what I've then done is I've made the list, I've divided every value in that list by 500. 500 is a randomly chosen number, but if I don't divide it by that, if I'm then trying to set my marker size points to be 5,000 or something, it's going to be way too big for our map. So you just need to play around and find out what is a good size to adjust your data set by. You could use some other way of transforming this, but for a lot of the times, what you're now seeing here is at least the big points will correspond to the largest GP surgeries, and then you can start to see the smaller GP surgeries as well. So just to give you an idea of what that actually looks like behind the scenes, when we pulled out the total list size from this data frame, we had, it was in the realms of thousands. We divide everything in it by 500, and you can see that our marker sizes are sort of ranging from somewhere around 1 up to maybe 100, and that's a much better size for displaying on this. So Getting towards the end of our additions to our plots now, we can add a title as well. It's easy to add a title to the plot. We use plt.title and whatever we want our title to be as a string. We can pass in an f string if we want to use some details from within our data frame, for example. But plt is referring back to matplotlib. Remember, we tend to import matplotlib.pyplot as plt, and then that will be forming part of our title. We can also use the special character \n to make a new line within our plots. So what we've got here is, the special character n, and this puts a line break in our title wherever we have this \n. We can see it doesn't go into the final title, it just makes a new line for us. Now labels get a little bit more complex. You can just always reuse this same little code snippet to add your labels in. But we need to use a for loop to iterate through each row in our data frame. We need to look at where the data frame, where that row relates to and the text we want to put in. And then we plot that for every single row in our data frame. What this is saying is for an X position, a Y position, and a label, we're looking at the geometry column, the X value of the geometry column, the Y value of the geometry column, and whatever our label column is. So here it's the name of the GP surgeries, that's just .name. If it's, your column could be called anything. It could be called, label, it could be called location, whatever you want to actually be the text that turns up on your map. And what we then do for each one of these, we are annotating our axis object with the label, the X and Y position we're passing in. We're saying, please offset it by a certain amount. So we don't want it directly over the points. That's what this XY text is. It's saying, please just move it a little bit off to the left and down, just so that we're not overlapping. And finally, we can say, please offset it by that. That's just what this text chords argument is. So just use this same format. It will always work for a matplotlib plot. That being said, you'll find quite often that they're not the most readable. If you've got lots of points that are in similar places, they will start to overlap each other. We can make a start on this by importing a module called text wrap. And when we use this, what we pull in, this first line is identical. We haven't changed this, but we look at our label column. So we've said X, Y, and label. Label is the values in this column here. And we've said, please wrap it to a maximum of 15 characters long. What I've also done here is use a text method to turn it into title case. Title case just means each word will start with a capital letter. The following letters won't, they'll be lowercase. So we had all capitals here. It's not the nicest to read. This just does all of them at once. Someone's also just asked, why is it zip in the for loop? So zip just turns these into a sort of one object. Also, it almost stacks them together in one object. So it's almost like sticking a column of X's, a column of Y's, and a column of names that it can then loop through and look at one group of them at a time. That I will try and come up with a better explanation of that as well. I think it might be helpful if I share a little bit more detail about how zip works, but hopefully that gives you a little bit of an insight into what zip is doing there and why it's necessary. So what we've done now, we've wrapped our label in each instance, we've made it shorter, we've basically forced it to go onto new lines after 15 characters, and then instead of just passing our standard label in, we've passed in this wrapped label instead. Now, I'm not going to go through this in detail, it's only an extension, but just to know there is an additional package you can use called adjust text that will allow, it will automatically iterate through, look at all of the labels that you're trying to put on and move them around effectively. It will work out the best place it can put each label to try and not overlap with other labels. This gets quite complicated. It's not the easiest library to use, but it's the best library I've so far come across for this in Matplotlib. We will talk about interactive mapping a little bit later. And actually, if you've got lots of long labels, you may find that this is more, interactive mapping might be more suitable for your purposes. But for the purposes of being able to add labels intelligently to maps, have a look at this slide on the adjust text library and have a think about what's going on here and in this section at the bottom. Again, you can just follow this pattern, it will work. Final thing I think to talk about quickly. Again, this is only in the extension exercise, so if you just want to get through the basics, don't worry too much about this, but it's useful to know that subplots are a really powerful way to map multiple columns at once. So here we had a column for antisocial behaviour, column for bicycle theft, a column for burglary, and so on. And in just a few lines of code, we've managed to create maps for each of them, each with their own legend, each, with their own settings, but well, not with their own settings, but each following the same colors, etc. They can be very useful to create, especially in automated reports. The first thing we need to do is set up some empty subplots using this standard line of matplotlib code. So what we're doing is saying, please create me a matplotlib figure. Please create me a series of axes within it. Please make this figure quite big, this big size argument here, 20 across, 15 tall, so we've got enough space to see everything within it. And I want 2 rows and 3 columns of subplots. So we can change this 2, we could change that to a 5 and we'd have 5 rows, change the 3 to 7, we'd have 7 columns, so on and so forth. You need to think about how it is being used to create, how many subplots do you actually want. We then move through each of these individual subplots and plot something on them. So I'm not going to go into this in as much detail as I planned because I feel like I've been talking for a long time and I want to give you some time to just actually play around with this. But effectively, we are saying for each, we're going through axis number 0, axis number 1, axis number 2, axis number 3. That is what the I is when we're going through our axes objects. The AX is a subplot. So this is subplot 1, subplot 2, subplot 3, subplot 4, 5, 6, and so on. What we're then saying is please plot, in this case, column 1 from my data set. And then please plot the legend, plot it to this particular axis, and set me a title. Now, how are we going to choose what we're looping over? Well, what we're doing here is we've passed in a list of column names. So these need to correspond to what the column is named in the data set. But then when you're working through what it's looking at when it goes cols 0, cols 1 is antisocial behavior, bicycle theft. It's pulling back these strings of text. It's making a text, an axis title that is this string of text, but it is also passing in, please plot me antisocial behavior. Please plot me bicycle theft, and so on. So the first time through, when we go through, it looks at antisocial behavior. It says, please plot the antisocial behavior column. Please place it on the first axis of my subplots, and please set that as the title, and so on and so forth for the additional plots. This code would just be to actually build the nice subplots we saw before. We start off by recording the limits we want. This is just showing you how it all builds up. We've gone through every part of this. Record the limits we want, filter the Geopandas data frame by this limit. We're going to then, in this case, we've renamed the columns in the geodata frame just to make them a bit more readable. You can see we've got these really long and nasty column names. Well, actually, we're going to rename them using this pandas method. We're then going to make a list containing just the column names we're interested in plotting. These need to match up to what the column names are in the data frame now. We're going to create our subplots. And then this is where we make the maps. And this is what we have. At the end of this section, we have these subplots. Finally, just if you want to save your maps out, which can be really valuable if you are looping through maps, you can just do plt.savefig at the end of where you've created your map, and it will come out as a JPEG, a PNG, whatever you specify in this little bit of code. There's loads of extra documentation on Geopandas and plotting, and there's some really nice examples in what I've linked here to some maps that have been created for some real world data. So please do take a look at those if you're interested in seeing more examples of maps. But for now, let's take the plots we started with earlier. We're going to open up exercise 4. And we're going to start working through some of the simple plots and start enhancing each of those with some of the customizations we've talked about here. There's also a new data set of dentist activity that I've loaded in. It will be, it will be pointed towards within the exercise notebook. Before I carry on, or before I send you all back to your groups, Dan, any questions?
So there were some questions, Sammy, that I think I've answered by Googling them. So hopefully they're the correct answers. There was one question about zip. I've given a nice little. So I can't remember. There's somewhere else I've seen zip in some old HSMA materials. I don't think it's in anywhere else this year. Zip is actually it's not something you'll use very often, but it's actually much simpler than it sounds. And that link that I posted in the chat gives a really, really simple example of it that just makes sense. So I encourage you to check that out if you want a simple example of how zip works. The other question was about whether the generated plot can be exported as a JSON map file to be used in things like Power BI. Well, as much as I just test Power BI, I think you can do that, and I've put in a link. But Sammy, I don't know if you've any experience of doing that.
No, it's not something I've done before, but that's a really interesting question. And yeah, I would be interested to try that out actually as well. If anyone does try it out, please do share your example with us, your Power BI file. That would be really cool to see. Like Dan, I come from a Power BI usage background. I do think Power BI does actually have some, it can be fantastic. It can do some really cool stuff, and it can be incredibly valuable as a tool for sharing your insights. But of course, we do love Python and free and open source. But if you're using, if you're using open source to get into closed source for generation, then that can be really powerful. Python, you can use Python to a certain extent within Power BI, but I don't know if Geopandas is likely to be one of the supported modules. I suspect it is not, due to just how problematic it is to make it play nice with other packages. So the exporting to JSON may be your best bet. You could automate that process potentially, actually have something that's automating those regularly, and then have be pointing towards that JSON within Power BI in some way. But that's all worth knowing. I will copy that zip link into the slides as well. But for now, I'll send you off into your breakout rooms. Have a go at exercise 4. So we're still in session 3B at the moment. This was meant to be after lunch. Unfortunately, due to timing, we've moved things back. So you're still in 3B, not 3C yet. And we're looking for the exercise notebook. It's called Enhancing Our Static Map Plots. So I'm going to give you about 25 minutes for this. So that will take us through to, let's say, 2:30. So we'll come back at 2:30, and then we'll move on to some interactive maps.